Hey everyone, welcome to our YouTube channel. So now that we have learned about what linear regression actually is and also gotten a geometric intuition about the same, let's quickly learn about the different assumptions that we have to keep in mind in order to use linear regression. So linear regression, as we can see, has this 5 assumptions. Let's understand each of them one by one. All right. The first part is linearity. Now, linear regression says that input and output should be uniform. That is, it should have a linear relationship between them. That is, whenever we plot the input and the output values, it should somehow show a relation, and it should not be a non-linear regression. For example, if we have something like an exponential function or a quadratic function over here, as we can see, or let's say the data points are very uniform, then we cannot apply a linear regression. For linear regression to get applied, the relation between input and output should be linear in nature. All right. Multicollinearity. So it says there should be no multicollinearity. So what is this multicollinearity? Let's say we have multiple features. Let's say we are trying to predict the house price for, uh, we just want to predict the house price given certain features. What are the different features given? Let's say number of rooms, number of bathrooms, washrooms, area, and price. So we want to predict what is the price given these 3 features. What does multicollinearity say? One feature should not affect the other feature. That is, number of rooms, if increased, should not affect the increment of number of bathrooms. If that happens, then there exists some sort of a multicollinearity, and that would degrade the model. In simple words, we cannot use a linear regression then. Multicollinearity in general is something that we should avoid. So for example, over here we can understand, right? If the number of rooms increase, area will surely increase. So number of rooms, if increase, area also increases. Increase, decrease, whatever it is, it changes linearly. So there exists some sort of multicollinearity, which is bad. Similarly for bathrooms, right? If the number of bathrooms increase, area still increases. So it involves some sort of a multicollinearity. And an assumption of linear regression is there should be no multicollinearity. All right, let's clear all this. Third, homoscedasticity. Now, what does homoscedasticity means? It means spread of error should be uniform. So basically, the errors that are spread over should be uniform in nature. Errors of historic data should not affect that of the present data. All right. So in simple words, the error present or error, you know, what do I say? Distribution should be very uniform. So this is the third assumption of linear regression. So this is nothing but the distribution of error, right? Distribution of error should be uniform in nature. It should not change with respect to the data points. Next, we have residual autocorrelation. So what linear regression assumes is there should be no autocorrelation of errors. That is, errors should not form any pattern. Again, very much related to homoscedasticity. Not exactly same, but related. The errors that we have should not form any pattern, let's say. If we see any pattern formation, it means there exists some sort of a residual autocorrelation. Normal distribution of errors. It also says that the distribution of errors with respect to time, that is frequency over here, right, 1 by time, should be uniform. a normal distribution. We all know, right? The normal curve or the bell curve. So distribution of error with respect to frequency should be normal, right? So these are the 5 assumptions that we have for linear regression, namely linearity, input and output should be linear in nature. Multicollinearity, there should exist no multicollinearity. That is, one feature should not affect the other. Homoscedasticity, that is, spread of errors should be uniform or equal. Residual autocorrelation, that is, no autocorrelation should, or in other words, errors should not form any pattern. Finally, normal distribution. The distribution of the errors should be normal, should form a normal curve, right? Or a bell curve. So these were all the 5 assumptions of linear regression. See you in the next lecture where we'll be building the linear regression model from scratch. Thank you.